So we're going to talk about quadratics in standard form today. Specifically, we're going to find their vertex. We're going to find their y-intercepts. Then we're going to use those two things to graph it. Then we'll talk about how to find the roots, which we kind of already know how to do, but we'll review it. Excellent. You can. Is there blanks that you guys need to fill in? Yeah. Okay, I'll wait for it. So, let's talk about the y-intercept first. First of all, you guys want to remember this is the standard form, right? I think earlier this chapter, we talked about graphing it when it was like this, right? So today we're doing it in this form. So the y-intercept, as you guys know, that's where it touches the y-axis, and when you're at the y-axis, the value of x is 0. So that's kind of like your big aha there, is that how do you find a y-intercept? You plug 0 in for x, and you solve for y. Okay, so once again, I'll state it. So the y-intercept where it touches the y-axis, and when you're on the y-axis, the x value is 0. So if you have an equation and you ever want to find out what the y-intercept is, then you just plug 0 in for x and you solve. Okay. So if we do that here, did I print the slide for you? No? I don't think you really need to write it. You can just watch. But if we plug in 0, that will help us find the y-intercept, right? Well, this is 0 squared, which is 0, times 5, which is 0. And then 8 times 0 is 0, and so your y-intercept is 3. And in standard form, it will always be like that. When you're in standard form, basically whenever you plug in 0, these two things go away and you're just left with that. And so what that means is that number there is your y-intercept. So you really don't have to even go through the steps of plugging in 0 for x to find your y-intercept. When it's in standard form, you can just look at that number. Now the reason I tell you why, or the way you find the y-intercept is by plugging 0, because that works on every equation. So for instance, if I gave you guys one of these, okay, the y-intercept, you can't see it anymore. You would have to plug in 0 for x and actually figure out what the y-intercept is. But when it's in standard form, you could just see it's that number right there. Okay? So pretty quick and easy. So what's my y-intercept here, guys? No. Okay? So let's go ahead and move on to that. Let's review what we learned. I think this was last class. Last class did we complete, change it from standard form to vertex form? Is that what we were doing last time? All right, so let's review that really quick, because that's going to help us with the next part. The next part I want to do is I want to talk about how can you find the vertex when you're in standard form. Okay, well, one long way to do it is to complete the square. Okay, so, but I'm going to give you a shortcut, so don't worry. But let's say we start here, right? The first thing that we did was we took the 5 to the other side, right? And you don't need to write this, you guys can just watch. But we took the 5 to the other side, right? Then we took the a out. We factored out the a, right? After that, we completed the square. We added that new number inside the parentheses, correct? And then we fixed our balance, so I put a 4. Actually, over here it should say 12, right? Not 4. Then we factored. This is going to be 7 now. And then we moved that 7 back over. So that's what we learned last time. And so now, what's our vertex there? Yep. I don't know if I printed this slide for you guys or not, but if I didn't, then don't worry about it, but I had a typo there. So anyway, so there's your vertex. Now what I'm about ready to do is I'm about ready to give you guys a way to jump from this number all the way down to this number without having to do all that work, okay? So, what's, from here to here, the 12 didn't change, right? But from here to here, what happened to the 12? It got divided by what? The 3. So in other words, this middle number, which I'm going to call the B, right, the B, got divided by the A, right? Then we went down another step, didn't change. What happened to the 4 here so that it became 2? It got cut in half, right? So if I take this and put a 2 on the bottom, that cuts it in half now, right? And then what? It stayed the same, and then what happened to the 2 there? You guys recognize that little piece there, right? You've seen that before? Negative b over 2a? That's what it is. That's where that little formula comes from. It comes from completing the square. And what this number is it's the x-coordinate of your vertex. Okay? And it comes about from completing the square. Now, getting the y value is a little bit trickier. You can make a formula for that as well by following the same process that I just did there, but it's a really ugly and lengthy formula. So instead of using a formula for that, I'm going to show you how we can find the y in another way. But what we're going to do to find our vertex when it's in standard form is, instead of doing all this, I'm just going to take my b value, I'm going to divide it by the a and by 2 and put a negative in front of it, and I can get to my answer right away. Okay? So now the question is, how do we get the y value so that we can get the vertex? Okay? Well, if you have an equation, right, and you have an x value, how can you find the y value? Just plug it in, and that's how we're going to do it. So we're going to find the x value using this formula, then we're going to plug it in to get the y value, and voila, we'll have our vertex. And this is kind of like what you were talking about, this shortcut last time. All right. So I believe I printed this slide for you. So here's how you find the vertex when you're in standard form. The h, which is the x part of your vertex, the h is going to be negative b over 2a. To find the k, which is the y part of your vertex, you just plug your answer from this into your equation and find the answer for y. Okay? And that's how we're going to find our vertex in standard form. We're also going to graph, but we'll come back to these steps in a minute. We're going to basically put together these two ideas that we talked about today to actually turn an equation into a graph from standard form. We learned how to graph when it's in vertex form, but we're going to learn a way to do it in standard form today. So we'll come back to these steps. But just so you guys know, the reason we do this is, you know, you might think, well, why don't we just say change it to vertex form and then everything becomes easy? Well, the problem is changing it to vertex form takes a lot of work. And the fact of the matter is, actually, even though vertex form is easier to work with almost everything, this is usually how quadratics are given to us, is in standard form. So we kind of need these shortcuts for dealing with standard form. All right, just kind of makes life a little bit easier. So once again, we're going to come back to this slide in a little bit to actually graph, but let's go ahead and begin here. Did I print this slide for you guys? Okay, cool. So let's do it. First of all, what's my y-intercept? 12, right? This number right here. We talked about that. That's nice and easy. Now we got to find the vertex. Now the vertex is going to take us some time. Okay, so not as much as it could, but we're gonna take some time. So we need to find the h, and then we need to find the k after that. Now to find the h, what I told you we're gonna do is we're gonna use our formula, negative b over 2a. All right. So here we go. My b is 8. My a is the number in front of the x squared, which in this case is 1. So we have negative 4. So that's the h part of my vertex. And the way that we said we were going to find the k is by plugging that number in to this equation. It's at the 2. All right, so let's find our k now. The k is what we would get if we plugged in the h value for x. So I'm kind of squishing it in there, but if you can't see it, it's negative 4 squared plus 8 times negative 4 plus 12. So that's going to be 16 minus 32 plus 12. Combining the first two there, I get negative 16. Negative 16 and 12 is negative 4. So my vertex will be negative 4, 4. Okay. So we found our y-intercept, we found our vertex, and usually at this point, I say usually because it's not always true, but usually at this point you have enough information to actually get a pretty decent graph out of this now, of your parabola. So let's go ahead and do that. This is part C now. Let's draw a graph. My biggest number is 12. Oh, this is supposed to be negative 4. My biggest number is 12, so I think I'm going to go up to 12 here. So let's plot our y-intercept. My y-intercept is 0, 12. It's going to be up here. Different color. And my vertex is negative 4, negative 4. So that's left 4, down 4. All right. So this has to be my vertex. There's only one way to draw this parabola. Okay? See if you guys can draw the parabola really quick, what you think it might look like. But the bottom one has to be the vertex. Okay, the only way this could have been drawn is like this. Because this has to be the vertex, right? And then it has to touch this point. And that's the only way you're going to get a parabola out of that. So just so you guys know, let's go back to that last slide there a little for a second. So how do you graph a quadratic equation when it's in standard form? The first thing you do is you find your vertex, right? Using these two steps we talked about. You also want to find your y-intercept. It's just the c value. Then you're going to, based on what you know about the shape of a parabola, you can find a third point. You guys know that with a parabola, the vertex cuts it right in the middle, right? So if there's a point over here, there should be one over there. Okay? So that's how I kind of know what the shape of that parabola should look like. So that's what this step here means. Is use the symmetry to find the third point. So if your vertex is here and you have a point here, just go straight across to the other side and you'll have your other point. But you may not even need to do that. Some of you guys may have gotten the right shape without that third point, and that's fine. Okay, but there you go. So now there is a downside to this method. The downside would be it's possible that the vertex is the y-intercept. Okay? In other words, it's possible that this point and this point are the same. So now you only have one point, and you really don't know which way the parabola goes, because you need at least 2 points to kind of figure that out, right? So if these two are the same point, you got a little bit of an issue. In that case, just pick another number, plug it in for x to get another point, and that way you'll have enough information. But that's the idea. So if I got this, for instance, then I might plug in like 1, so I can find another point over here, and then I can figure out what shape I have. All right. So there you guys go. That's how you graph. So let's do one here. Did I print this for you guys? Probably not, no? Okay, go ahead and write down the problem. Amanda D. What do you think the y-intercept is for this problem? Yep. I'm going to write it as a point, though, so I'm going to put 0, 6, but yes, it is 6. All right. Next, I want you guys to find for me we're going to start finding the vertex. And to find your vertex, it's a 2-step process. You need to find h, and you need to find k. So the first thing I want you guys to do is I want you to find h. Go ahead and see if you can find your h. I'll give you a second. Good. Now I'm going to encourage you guys to change it to a decimal, but 5/2 is correct. So it's negative b over 2 times a. B is 5, a is -1. So you end up with -5 over -2, which is 5/2, and we're going to change it to a decimal of 2.5. Okay? Now I want you guys to go ahead and find your k. Feel free to use your cell phones because you're going to have to do some calculation with a decimal, and that's okay. Follow your order of operations, right? PEMDAS, exponents first, then multiplication, then addition and subtraction from left to right. So when you're graphing your decimal, it's how do you graph a decimal? Well, go over 2 and then a half, a little bit more, right? Same thing with 12.25. Go up 12 and then up a little bit more for 0.25. We don't have to be horribly precise. So over 2.5 and up 12.5. 0.25. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So over 2.5 and up 12.25 is going to be like right about there. My y-intercept is 0, 6. Now, if this is my vertex, the only way to connect these dots, remember, this is like your middle. So if you want to find a third point, you would just go straight across. It would have to look like that. Okay? All right. So that was a guided practice. So I'd like to get to do one more, but the whole thing on your own from beginning to end. See if you guys can get your final graph there. Huh. I'm not getting a response from my technology. All right. Fair enough. All right, so they're just due to practice, guys. I'll give you guys like, maybe like 4 minutes. So, all right. It's not supposed to be a negative there, so I will erase it since it won't undo it. Okay, let's move along. Roots. We've already done this. we want to, if you guys want to find out where it touches the x-axis, those are what we call the roots or the x-intercepts. What do you guys notice about the y values? They're 0. So in the same way that you find the y-intercept, you plug, remember you plug 0 in for x and you solve for y? Well, to find your x-intercept, you plug 0 in for y and solve for x. Okay? Now, we've seen this before. When you have a quadratic in standard form and it equals 0, how do you solve for x? That's how you find the root. That's how you find where it touches the x-axis. Okay? So I just want to kind of bring that home a little bit to actually connect the math that we learned on that day to the graph, because today we're looking at graphs. So let's go ahead and do that. So go ahead and write down this example if you haven't already. And you might want to draw the graph too. Just make it kind of look like that. We're not being real precise here. The goal is I want to figure out where does this parabola touch the x-axis. That's what I want to figure out. Now we're going to price solve. We're going to do the quadratic formula pretty much the same all the way through until we get to the square root step. At that point, we're just going to pull out our calculators and we're just going to do decimals today. The reason is because you guys know sometimes when you're doing these quadratic formulas, you get funky looking answers like this, right? You can't really graph that. I mean, what is that? What does that equal? I mean, that's a weird looking number. That's how they have us write the answer, but we don't want to graph that. So what we're going to do instead is, instead of simplifying the square root and getting that expression to look all nice and clean, we're just gonna turn everything into decimals. We're gonna get a nice solid number that we can actually graph. Okay, so we're gonna follow this. That's pretty much the same. It's just that when we get to that square root, the calculator is gonna be our guide from there. Okay, so let's go ahead and do it. I want to find these roots here, and that's where my quadratic equals 0. And when you have a quadratic equation in standard form equal to 0, the way you find the x value is by doing the quadratic formula. So my b is 8, my a is 1, my c is 12. Okay, so 64 take away 48. I don't know. Oh, well, that's lame. We don't even need our calculators. We could do this without a calculator. I want you guys to see how to do it with a calculator, but oh well, we'll just do this one. We could just do this by hand, because we know what the square root of 16 is. What is that? 21. 21? Nah. Square root of 16 is 4, right? Sure. So at this point, I'm going to split this up, because you guys see that plus and minus? Yeah. Oh, two. That basically means you have two things going on. We have one where we're doing -8 plus 4, and we have another one where we're doing -8 minus 4. So you're getting two answers, and that makes sense because look how many places it touches the x-axis, twice. So it makes sense that you're going to have two equations there. So we're going to write this twice, one where it's -8 plus 4, and one where it's -8 minus 4. All right, so for the top, that would be -2, and for the bottom, that would be -6. So then what are these 2 points? This one would be -6, 0, and this one would be -2, 0. So basically, quadratic formula tells you where your parabola touches the x-axis. Okay? What number's right in the middle of -6 and -2, you guys? -4. Now, why am I telling you that? Because your vertex will always be right in the middle of those. So if you wanted to, you can also find your vertex now at this point if you wanted to. We're not going to worry about that. I'm just kind of giving you guys some extra options here. But for now, just make sure you know how to find your roots. So the way you find roots is quadratic formula. Simplify it all the way to get some answers, and then you know what your roots are. Okay. Your turn. I would like you guys to tell me, what are these two roots here? And that'll end us for the day there when you're done. So to find your roots, you plug in 0 for x. Wow. I don't know if we'll be able to do it in words. Wigging out on me. Maybe I need a different pen. I don't know where my other pen is, though. The pen's just not working. All right. Well, I can't really write right now, but when you guys plug it in, you should have ended up with -7, 0.
Negative z.
Yeah. -7, 0 over here, and +1, 0 over here.
You made it look like it was a big gap. That's why I'm like, I got -22.
Now, just so you guys know, there is another way to find the roots, and I'm not sharing that with you right now. We will later in the year. And for some of you, it may be faster, so I'll share with you what it is now. But the reason I'm not sharing that strategy is because it doesn't always work, but it would with these ones. Let me see, is this going to work? It's factoring. If you guys remember how to factor, you could factor this polynomial instead. And what you do is you set each piece equal to 0 and solve. This one, if you set it equal to 0 and solve, would give you -7. And this one would give you 1. So you can see that's a little bit faster. But the only downside to that method is not every polynomial can be factored. But the quadratic formula always works. Okay? So that's why I didn't want to get into that yet. But you know, if you're good at factoring and you want to try it, save yourself some time, you can. Okay? But that closes us out for the day.